Okay, continue. Now I want to integrate this kind of thinking in our skeleton, so that you can juggle around with it and make your gymnastics. So we started just like a recap to these things. The Master of Art in our cultural history is, so this was bachelor studies for 2,000 years, geometry, astronomy, arithmetic, and music. So we correlated that in lecture 4 with the body of an expression, with the head of the expression, with the expression, and then the evaluation. So, and this is the circle around this point here. Is what happens. So we have the body, now we have the head and the body. So this is what we have, kind of geometry as a list. This is what we want to do with it. This is a kind of multiplication of this list. Do something with it. So that's body and head. So this here is there explicitly, or it has been evaluated. So this is 5. So we have the in, it's the expression, and the evaluation, the result of the evaluation is that. So we make a circle. So we have the expression, we evaluate that, and then we are in a body again. So that's a circle. We have the body, we have the head, we have the expression, and evaluate that, and we are back at the body. So that's geometry, astronomy. So geometry is what is there. Then looking to the stars, make the addition. So then make the, so say, okay, arithmetics, this is how this is orchestrated. So the starting of your arithmetical machine, your calculation machine. So do it, and then you're back with the sum. So the doing is the music of it. So, and then you are back with the geometrical part, symbolizing whatever you want. The 5 in this case. So this is how the calculus works, and it corresponds to the Master of Arts. So now look at this. We have the concept of double articulation. It's with Deleuze-Guattari in 1000 Mille Plateau. You have the link here. It's very important. Read that. It's you can, here it is, 1,000 pages. English. So it's not the idea. So the way how our class works has a lot to do with it. So it's not the idea that you understand what is written there or what a double articulation is. So it's like our evaluation, expression, body, head, and so on. It's turning around a centered void, something which is not there. So it's simply stabilizing something which is not there. So it's the same with these 1,000 pages of Deleuze and Guattari. So you're rotating around, and don't try to understand them. Very important. Read it if you like. Read the 1,000 pages. It's rich, and after a certain time, you get it's a kind of warm feeling with these concepts. So a lot of strange concepts, like with me. So playing around, they're juggled, interesting story, super fantastic, some are very precise. So, and it's juggling around with the things. Don't try to understand or ask why. It's simply these kind of rotations around the centered void. So if you're interested in these things, I strongly recommend that. So the problem is, don't trust any explanation or assistance. For example, with Manuel de Landa, it's incredible because he's making a photo and sticking it, and it's making it dead to the point, and then it's not flying anymore. He's trying to explain it in a certain way. So, especially here, he is putting it to the body. So, Chuck is getting the whole nice story and Chuck and say, it's the body. What you are talking about? It's the body. I explain it. It's simple. Don't. Yeah? I can make it in 100 pages what they did with 1,000. Don't trust it. Don't read it. Don't touch it. This should fly. So, and keep it like that. So I wanted to put reading and writing into this double articulation. So if you have the reading and writing as a geometrical thing, as a list, you have two elements. If you connect that, then you have reading looking at reading, reading looking at writing, writing looking at writing, writing looking at reading. So this is writing at writing, reading at writing, writing at writing, reading at reading, writing at reading. So it's a very schematic setup of certain symmetries. So, and I would associate geometry with that, astronomy with that, arithmetics with that, music with that. We always had with reading and writing and so on, but now we got it double, crisscross, looking at itself, getting the kind of multiplication of things. So having one double, getting another one double, and crossing it. Making a multiplication on our twofold schemes. So the same here with our schemes. Now we have this infinite line, and the point on this line in Renaissance is reflecting the irrational circle around. This is geometry. If you take that and project it here, so this is reading of the writing. This is writing of the writing. This is reading of the reading, getting the painting of to project the whole infinite line to this irrational circle, and this is writing of reading. So it's a little, it takes too long to. It's more about anchor points of meditating around these things. So, when this is writing of writing, it's the outside of the Renaissance, the sculpture, the graphics. Yeah? The graphic is with geometry, it's with air in this setup. This. And this is the start of the heliocentric work. If you go to self-reflection of that, this is the inside of enlightenment, it's a sculptural painting, it's graph, logic, and harmony, it's with fire. So reading and of reading, inside of Renaissance, painting, images with arithmetics, it's with the earth. Writing of reading, outside of classicism and enlightenment, painted sculpture, it's a plot is with music, and this is with water. So, here we are. We had these setup. This is Palladio outside, writing, reading. So we said this is a sculpture, and this is painting. This is inside. This is Schinkel, for example. This is no, I'm not fit enough. You see how. So writing, writing, reading, reading, writing of reading, and reading of writing. But what you see is that we can have multiple axes. So you have the sculptural thing here, so it's expressive and it's getting volumes. These are sculptural and they are with the light. So the light is external, here and here. And they are sculptural. On the other side, it's not about light. The light is somehow there. And it's flat and it's about painting. This is what I say, it's a reading. So you're reading the world as a circle in a painting. And you're reading that and making that as an object. But this is an object quite different from this one. It's painted. So it's a painting which got written, which got sculpture. This is a sculpture which got painting. So you have sculptural, pictorial. So you have the outside in this axis, you have the inside of this axis. Yeah, you have the Enlightenment here, and you have the axis from Renaissance here. Outside Renaissance, inside Renaissance, outside Enlightenment, inside Enlightenment. Inside, outside. So as I told you, you can change pictures, you can change artifacts of Renaissance, put the outside here, it always works. Put the inside of these artifacts here, it always works. We made that with texts, with poems of Shakespeare, it's working like that. And do the same with 18th, 19th century paintings or artifacts, it always works on this axis. So associate that with the Platonic solids, with the air, the water, the fire, and the earth. It's working like that. And then you get stability in these elements. So with reading and writing, we do have painted sculpture, painted painting, sculptural painting, sculptural sculpture. Or we go with the Aristotelian elements or with the Platonic solids. You see here, the air is hot and wet, the fire is hot and dry, the water is cold and wet, the earth is cold and dry. So you see exactly the same kind of symmetries. And the corresponding Platonic solids. Fire, tetrahedron. No. What is this? So you have the fire, the earth, the cube, you have the dodecahedron, and you have this. You have the Platonic solids like that. And in the center, the ether. That's very important. People don't like this. In all the things, you always have four. But you have the fifth element, and it's always, it's called the ether, with Plato and with the Timaeus, and with Aristotle. And to my understanding, this is this centered void around things rotating. And you have always these 5 divisions of circles making the volume, which is the most irrational setup possible. So, if we want to go to graph and graphics, I would say We have the graphic here. This is sculptural sculpture. This is graph is painted sculpture. This is painted painting. And this is sculptural painting. We have the prototypical setup here. It's a graphic, the triangle. We have the graph, which is an abstraction of the graphics because you don't have the points. So it's with the astronomy with the points and looking for symmetries here in rotation. If you bring that to Earth like Ptolemy, it's arithmetics and you're with the image. And if you get sculptural view to image, you are with the plot. So these are the 4 forms important. There is no more. So we can go in detail how this works. We had that. We have the rules, 1 to 2, 2 to 3, 3 to 1, with the graph. So this is how a graph works. Now we go to plot. So this is a graph. So the inside of this is the inside of enlightenment, pure structure. Now we go to the outside of enlightenment. So this is Schinkel outside. We do it like that. So we have a parametric plot, and there's a whole family of different functions being able to do that. So you have infinite, you see it's not a pixel, it's not a vector, it's infinite curved, infinite position, curved lines. And you simply say, here we have coordinates, that's the x coordinate, that's the y coordinate, and we plot that with a variable alpha. Alpha goes from 0 to 2 pi, which is one circle. So alpha goes from 0 to 2 pi, and depending on alpha, x is calculated with this function, and y is calculated with this function. Now you know sin is the unpackaged, it's a adjacent leg, and it's the I don't know in English. Put that in x and y. X multiplied with, so x makes two circles on an A plus a face of a quarter of a circle. It makes 2 in x. And in y you make 3 in a circle and another offset, a 6 of a circle. If you run that, you get this diagram. So you see that there are these rhythms. You have 2 and 1 and 3 in this direction. So we go here, for example, to 3, then we get a certain symmetry. They are in sync. If you go to 5, you get quite different setting. If you change that, so this is how to get certain numbers in the sculptural thing. How these numbers get not a picture but a sculpture in domesticating or harmonizing a space. We're doing it with these functions. We've seen the whole story with a density plot. If you look at these proportions here, if it's low, it's black. If it's high, it's white. And you get these kind of proportions, 3 to 2, here 3 to 2, and you get the density plot. It's the same story. To harmonize and and tune space. Here you see how it works with interactively. We have three of these variables. That's the frequency, the amplitude of the first frequency, amplitude of the second, yeah. How to sync these to get a certain harmony in space. And it's a painted sculpture. This is what we have in classicism in architecture, at the outside. So if you have a tonnage here, that's it. Beaux-Arts, that's it. They are fascinated by these domesticating and orchestrating of space by very few ratios of numbers and getting this stable in balance. So it's very fascinating if you have, for example, Frei Otto, or now with these minimal surfaces and these hanging things with Gaudi, Antoni Gaudi. It's a fascination of that. Just getting things tuned by very few numbers in space. Good. That's the plot. It's here. It's a sculptural painting. This is a painted painting. We had that last week. And this is a painted sculpture, which I think the graph is. Now the image, very simple. So we had that. We have a list, and simply make this area plot and then you have it here. The graphic, we had it already, just to compress it again. Just these numbers, and give these numbers certain coordinates in space, say it should be a graphics, and you get this result. This is cultural sculpture. And this is what we have in Renaissance at the outside. This is Renaissance outside, Renaissance inside, Enlightenment outside, Enlightenment inside. And we are with these pictures. Graphics, graph, image, plot. If you go to this abstraction, and this, as I exemplified that with the graphs, with Cuvier and so on, if you go in this abstraction in these times of the architects or other artifacts in medicine and in politics and in economy and so on, biology, chemistry, you find always the same setup in thinking. As I told you, if these abstractions are powerful and mathematics is the key for that, because they all use the same, masters of their time use the same kind of thinking, and mathematics is the key for that, because it's the only discipline, if it is a discipline, which is not corrupted by any application. By that, it's the most direct access to the thinking of a certain time. And this is always consistent in a time. And you always have to think in the outside and the inside. What is incorporated, what is sheltered as privacy, and what is public. And what you're doing is you're turning these two things over time. You're turning it like a helix. Turning it around over time. And by that you get symmetries in time over centuries to learn. Okay. So we had now a few things. London Tube, we had that. I think we have that as well. Just to give you, so these graphs. So we are in the scheme of enlightenment. We are with the plots, and the internal stuff are the graphs. So you have these classification. There are a huge amount of classes, like with species on graphs. They have a huge amount of parameters. There are thousands of them. These are a few examples. We have these symmetry groups. We have these kind of combinatoric things that you want to have in a certain setup. You want to have neighbors of different colors, and you want to have the minimum amount of colors to cover the whole story. So this is with 4 colors, this is with 2. This is a library of 44,000 molecules in chemistry with all the parameters. Now you see this is a graph. What is it? It's a graph. Simply can work on it. You see the adjacency graph, so this is a matrix, which element is connected with which one. This is the plot of that. You understand it, it's always the same. And this is a nice 3D graphics of it. So, nothing spectacular about it. So, and at your fingertip now has 44,000 of these. So the same with lexical data. So there are 150,000 words in a dictionary. It's called word data. You have 37 properties to each of these words. And for example, this is a graph around the concept corner. These are the neighbors of the corner. Or these are the neighbors of the corners to level 2. So tree and corner and so on. So these are all the graphs. Level 3. This is a matrix on synonyms of level 3 on corner or tree. These are graphs on dictionaries. Geographical data. Look at this. You go to OpenStreetMap, Google Maps, import that. You will have that next semester. This is a graph. You get shortest path from A to B. Calculate that. Here, get all the tram stations, get arrows, get the shortest path. This is a matrix of the city of Zurich and its connectivity. So it's very clear how this works. This is a graph, yeah, the matrix of that. Social media. These are your friends in Facebook. Cluster them and so on. Or these are constructions. Huh? Getting them to minimal surface or to optimize them to a certain functionality. Get a shape and to a certain form. This is how it is done. And in this case, it's a single line of code because you have a certain graph and you put it for example, to the gravity. That's it. And then you have a certain form. By that, the shape falls into a certain form, like Gaudi. Makes the graph and put it to gravity, and then you have it. It's one line. Or here, have a nice setup here, and then I get some tensions to the edges, like some tension to that, and then they open up and get certain meshes up. Okay. This is, if you have a graph, shortest path, we add that. This is an interesting, you get integer numbers, pairs, you get why is it not working anymore? So you have 10 elements. No, you have random integer number between 0 and 10. You get 12 pairs of two numbers. So these are there. So then you take that as a graph and look for the shortest tour. So take these points in plane, takes the shortest tour to get them. Get this, connect them, and plot it. Do that 100 times. Defaults are a little so, and you get these kind of nice shapes. Very simple, clear applications. Very important is that you can find cycles in paths. So if you have things like that, or if you have then this is a skeleton graph. So it's a projection to ground. This might be the city map of Zurich, of Switzerland. Put that, you know that, and now I can find cycles of exactly length 3. So I get all these cycles of 3 automatically. And now I recombine it to my thing and make a nice graphics out of it. Or if you have that, the spanning tree. To get things. So I think this is a kind of parade of what you can do with it. You got the principal concepts, and this is what I want to tell you about graphs. Next week we will have graphics, and then it's much more, it's not about the principles, how to work with it and how to get connections, how to do that, but to get a very precise graphical presentation of that, to make it sculptural. So this is very conceptual. This is a painted structure. So therefore, it's a reading of sculpture. So it's the principles behind all the structures you have. The graph, all things are connected. They have no form, so it's the principles of that. It's a reading of it. So tomorrow and the next week we will have it actually rendered and real geometry. This is what we know from CAD systems in a classical way. Okay, that's it for today. Thank you.